Alright, space cadets, let's talk planets. Have you ever gazed up at the night sky and wondered how those twinkling dots came to be? Well, buckle up, because we're about to embark on a cosmic journey. Ever wondered how these massive celestial bodies come to be? It's a tale as old as the universe itself, filled with mystery and wonder. Picture this, a vast cloud of gas and dust just chilling in space. This is where the magic begins. These clouds, known as nebulae, are the birthplaces of stars and planets. We call this a protoplanetary disk. It's a swirling mass of gas and dust that orbits a young star, like a cosmic dance floor. It's like the cosmic nursery for baby planets. Here, amidst the chaos, the building blocks of planets begin to take shape. Now, imagine tiny particles of dust, like cosmic dust bunnies, bumping into each other. These minuscule particles are the seeds of future planets. They stick together, thanks to static electricity and gravity. It's like a cosmic game of bumper cars, where every collision counts. Over millions of years, these collisions create bigger and bigger clumps. These clumps, known as planetesimals, are the precursors to planets. Think of it like rolling a snowball, except on a cosmic scale. As the snowball rolls, it gathers more snow, growing larger and larger. This process, my friends, is called accretion. It's the gradual growth of objects by the accumulation of matter. It's the driving force behind planet formation. Without accretion, our solar system would be a very different place. As these clumps grow, their gravity gets stronger, pulling in even more material. This gravitational pull is crucial in shaping the planets. Over time, they become bona fide planets. Pretty cool, right? From tiny dust particles to majestic planets, the journey is nothing short of extraordinary. Now, not all parts of a protoplanetary disk are created equal. Just like finding the perfect apartment in the city, location is everything. The sweet spot for planet formation is called the habitable zone. This is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold. Like Goldilocks porridge. Why is liquid water so important? Because it's essential for life as we know it. Finding a planet in the habitable zone is like hitting the cosmic jackpot. It means there's a chance, however slim, that life could exist there. And who knows, maybe one day we'll find our cosmic neighbors. So how do we find these exoplanets, these planets outside our solar system? It's a fascinating process that combines the brilliance of historical astronomers with modern technology. Enter Johannes Kepler, the OG astronomer who figured out how planets move. Kepler's work in the early 17th century laid the foundation for our understanding of planetary motion. His 3 laws of planetary motion are like a cosmic GPS for astronomers. These laws help us predict the movements of planets with incredible accuracy. Kepler's laws tell us that planets orbit stars in ellipses, not perfect circles. This was a revolutionary idea at the time and changed the way we look at the cosmos. They also reveal how a planet's orbital period, the time it takes to orbit its star, is related to its distance from the star. The closer a planet is to its star, the shorter its orbital period. Basically, the farther away a planet is, the longer it takes to complete an orbit. This relationship is crucial for understanding the dynamics of planetary systems. These laws are crucial for detecting exoplanets. By applying Kepler's principles, astronomers can identify planets that are light years away from us. By observing the tiny wobbles in a star's movement caused by the gravitational pull of an orbiting planet, astronomers can use Kepler's laws to determine the planet's size and orbital period. This method, known as the radial velocity technique, has been instrumental in discovering many exoplanets. It's like cosmic detective work. Each discovery brings us closer to understanding the vast universe we live in and our place within it. The search for exoplanets continues to be one of the most exciting frontiers in astronomy. Now, not every celestial body gets to be called a planet. There are some ground rules, you know? First off, size matters. To be considered a planet, an object needs to be big enough for its own gravity to shape it into a sphere. We're talking at least 4,880 kilometers in diameter. Anything smaller, and you're just a dwarf planet. Sorry, Pluto. Mass is also important. A planet needs enough mass to clear its orbital path of other debris. Think of it like a cosmic vacuum cleaner sucking up all the leftover dust and rocks. So, to be a card-carrying member of the Planet Club, you need to be big, round, and able to throw your weight around. Section 5: Water, Atmosphere, and Other Must-Haves. We've talked about size and location, but what else makes a planet potentially habitable? Beyond just being in the right place, A planet needs several critical components to support life. These components are not just nice-to-haves, they are essential for creating an environment where life can not only emerge, but also thrive. Well, besides being in the habitable zone, a planet needs a few key ingredients. First and foremost, water. Water is the cornerstone of life as we know it. It is the medium in which the chemistry of life happens. Without water, the complex molecules that make up living organisms simply can't form or function. And not just a little puddle, we're talking oceans of the stuff. Large bodies of water are crucial because they provide a stable environment for life to develop. Oceans can help moderate a planet's climate, making it more stable and hospitable over long periods. Water is essential for life as we know it. It acts as a solvent, transporting nutrients and facilitating chemical reactions. These reactions are the basis of metabolism, the process by which living things convert energy from their environment into forms they can use to grow and reproduce. It acts as a solvent, transporting nutrients and facilitating chemical reactions. Water's unique properties, such as its ability to dissolve a wide range of substances, make it an ideal medium for the complex chemistry of life. It also helps in the transport of nutrients and waste products within organisms. It also helps regulate temperature and protects life from harmful radiation. Water has a high heat capacity, meaning it can absorb and store large amounts of heat without changing temperature drastically. This property helps to stabilize a planet's climate, making it more conducive to life. No water, no life, at least not the kind we're familiar with. Next up, atmosphere. An atmosphere is crucial for protecting life from the harsh conditions of space. It acts as a shield against harmful radiation and helps to maintain a stable climate. A planet needs a protective blanket of gases to shield it from the harsh realities of space. This atmosphere should contain the right mix of gases like nitrogen and oxygen to support life. These gases are essential for processes like respiration and photosynthesis, which are vital for most forms of life on Earth. This atmosphere should contain the right mix of gases like nitrogen and oxygen to support life. Oxygen is crucial for the respiration of most living organisms, while nitrogen is a key component of amino acids and proteins, which are the building blocks of life. It also needs to be thick enough to trap heat and regulate temperature. A stable atmosphere helps to keep a planet's surface temperature within a range that is suitable for life. Without this, a planet could experience extreme temperature fluctuations that would make it inhospitable. Finally, a stable climate is key. A planet with a stable climate provides a consistent environment where life can develop and evolve over time. This stability is crucial for the long-term survival of ecosystems. Wild temperature swings, constant volcanic eruptions, or a runaway greenhouse effect are all deal-breakers for life as we know it. These extreme conditions can disrupt the delicate balance needed for life to thrive. A planet needs a relatively stable and predictable climate for life to thrive. This stability allows for the development of complex ecosystems and the evolution of diverse forms of life. In summary, for a planet to be habitable, it needs water, a protective atmosphere, and a stable climate. These elements work together to create an environment where life can flourish. Now let's talk about the big boys of our solar system, the gas giants. Jupiter, Saturn, Uranus, Neptune. These behemoths are in a league of their own, but how did they get so massive? The answer lies in a process called core accretion. Imagine a baby gas giant, just a humble core of rock and ice. This core acts like a gravitational magnet, pulling in gas and dust from the surrounding protoplanetary disk. As the core grows, so does its gravity, attracting even more material. Over time, this runaway process creates a massive atmosphere of hydrogen and helium, surrounding the relatively small core. These gas giants are like the cosmic vacuum cleaners of the solar system, gobbling up any leftover gas and dust. Okay, enough serious science talk. Let's lighten the mood with some space humor. Why don't aliens abduct clowns? Because they're afraid of their hilarious probes. Get it? Probes? Okay, maybe not my best work. But seriously, exploring the cosmos is an awe-inspiring endeavor, but that doesn't mean we can't have a little fun with it. After all, laughter is the best medicine, even in space. So we've covered the basics of planet formation. Now you're probably thinking, hey, I could build one of those. Well, in theory maybe, but it's a tad more complicated than baking a cake. First, you'd need a whole lot of raw materials: gas, dust, ice, maybe a sprinkle of heavy elements for flavor. Then you'd need a star to provide the gravitational glue to hold it all together. And don't forget about time. We're talking billions of years for a planet to form naturally. So while building a planet from scratch might be a bit ambitious, understanding the science behind it is a journey worth taking. It's a testament to the incredible forces at play in our universe and the sheer elegance of the natural world. As we conclude our cosmic journey, let's recap what we've learned. Planets are born from swirling disks of gas and dust, sculpted by gravity over eons. The habitable zone is the sweet spot for life where liquid water can exist. Kepler's laws help us track these celestial wanderers, revealing their size and orbit. And while building a planet might be beyond our current capabilities, understanding the science behind it is a journey worth taking. So, the next time you gaze up at the night sky, remember the incredible processes that created the celestial tapestry we call home. And who knows, maybe one day we'll discover new worlds, teeming with life, waiting to be explored. Until then, keep looking up. Keep